I'd like to turn to our featured modeler this evening, Paul Woosen. Paul is going to talk to us about the NMRA's LCC program.
First of all, I'd like to say, before I get into the presentation, because the presentation gets a little technical in that, and to answer some of your questions, a lot of things have happened in the area of accessories that have gone into being hooked up to DCC or being hooked up to the just power. We see these LED devices hooked up, many different proprietary systems that have been put together to allow people to put in lights and put in signals and so forth. And unlike the issue that we came up with for controlling our models when running on the track, DCC, where there was some consensus and people followed some standards to make everything work together. Most of the individual lighting devices, lighting buildings, lighting signals, controlling different things have been done by different manufacturers and are not compatible. And so when we get into looking at this, we look at it, we'll see there's modules that you can put together and large layouts. Yeah, you'll see at the end of the presentation, there's a pretty large layout down in Arizona that is completely LCC, but small layouts can benefit. If you do nothing more than build a passing siding with a couple of LCC devices and put full signaling. You know, we talk about having foreground models. If you had your passing siding right near the front of your layout, small layout, passing siding, you're going to have a couple of turnouts and you want to have complete lighting for it. The LCC controls that you can get and put together, I'll show an example of that this time around, and we'll get into it a little bit, but you could have, you know, extremely nice models of signals, tricolor, multi-head signals out there at your passing siding on each end, and all controlled by the dispatcher and by the fact that you've got occupancy on the track itself. So all of these things can be taken care of, but the main thing that I want to emphasize is that LCC is next to, and I'll be saying this again in the presentation, but LCC runs next to the track. DCC runs things on the track, LCC runs your accessories. And one of the things that would, you know, we'll probably hit on, and I'll kind of zip through it, is that you don't have to get involved with using your DCC controller to control your turnouts or to control different things on the layout that are not running the actual locomotive. So you don't tie up bandwidth on your DCC systems. You don't tie up other use of the DCC system. You might not delay your whistle by someone else switching a switch and things like that. You use the push button controls or the LCC control systems to go with this. So let me go in. Let me first of all see that I can get my screen displayed here. We tried it out and it worked. and we'll go on into my presentation, but feel free to jump in and throw out some questions here. I think I'll hear everybody and everything else. So I'm going to go down here to my share screen and go here and back up to my first presentation. And this should get us going with the question of what is LCC. And first of all, I have to throw this up here because LCC is actually a registered trademark or registered trademark of the NMRA. And if I use it and I make presentations, I have to have approval of the General Counsel. This was presented to me early last year, right before the pandemic, when I was doing a live presentation, and that there was some issues of having LCC and the logo and so forth. So I made some quick connections, and the General Counsel gave me permission to do this as long as I put this statement up here. And so to get into it, the LCC, what it was proposed for about a decade ago was to create an open, license-free method to interface the activities with your layout. The intent was to be like DCC and have the manufacturers follow along to make the products interchangeable. So signals, you might have signals from 2 or 3 different companies, or lighting systems, things that went along that were interchangeable, and you could connect up to your system as it grew. And so their proposal was for the license-free standard with communication. They wanted extremely robust and viable electronics. So we see right now we have chip issues. You can't get cars, you can't get, I understand the trolling motor manufacturer has a complete warehouse full of trolling motors that are ready to ship, except for one chip hasn't arrived yet. The concept of peer-to-peer design was built into the LCC requirements so that it didn't require a central control. You didn't have to have a computer controlling it. You have to have a computer, though, to set it all up. And any 2 manufacturers could exchange equipment, could exchange data back and forth because there's inputs and outputs, which we'll get to talk about here in a minute. So what all is it? Well, it's we call it a superhighway for accessories for your model railroads. And it provides a language to talk to the accessories for functions, things like turnouts, block detection, signals, road crossings can be set up to detect trains coming and have and actually control the flashing lights or bring down your gates. You can have building and structure lights that can be turned on or turned off with a real-time clock that sends a signal down through LCC. I'm not going to get into all the details of how it all can happen, but you know, with controlling your turnout motor, you might have a reverse loop that you need when the caboose clears the track. It will flip the reverse, it'll flip the motor, and you're ready to come back out. You can have the signals that are associated with that change if you set the functions up using these cards. And then if there's a grade crossing, the grade crossing goes off as the train approaches and will stay on until the train leaves that block. as I say, building lights, ambient lights, if you control the color of the lights for day and night, again, a real-time clock function, you can change that by sending signals over your LCC. These are all things that you can do. You can interface, you've probably heard or read in the magazines, the Arduinos and the some of the other small computers, PICs and things like that were presented at National last year, and the Raspberry Pi. You can interface to all of those things. Here's a basic idea. The DCC is operating your trains. You have the power to the track. It's one way, really, in that the DC, it's meant one way, let's put it that way, that you send information from your cab, which is proprietary, really, to a control point that then sends DCC code via the square wave AC that goes out to your track, which is picked up by your decoder, received, and then an action is taken. And each decoder is independent. It has an address. Usually it's your locomotive number. Now, people have put other accessories on there that takes up bandwidth in the DCC and then put some limitations. LCC operates around the outside of the layout. It doesn't connect to the track. You might have a wire passing through a transformer that says there's current going there to detect that there's a train out on the track. It does have two-way communications, and everything in DCC hears everything that's going on. And we'll touch on that in just a little bit. So the idea is to make them complementary. On the track for DCC, beside the track for LCC. On the track, it's master-slave with fixed addressing. Beside the track, you have the LCC, which can be bidirectional. And we've seen, as I say, crossovers. There's a number of companies. I mean, you know, you got LocoNet, you got CMRI, who's been around for a long time. Many of these, and they're proprietary systems. So if you use one of those systems, that's what you're going to use, and you're not going to take a LocoNet necessarily and put it in with some of the other like LCC or NEC or some of their systems to make them work. You kind of have to stay with the one that you went with, which was an idea that was not meant to happen with the advent of LCC. I'm going to skip through here in that, yes, we know how this is all designed, and that we have command stations and so forth that are proprietary, and then they send out a signal that is according to the NMRA standard.
Paul, can I ask a question?
Yeah. Go ahead.
You mentioned these crossovers. Let me make sure I understand what you said so far. I've got to have two separate power sources, one to operate my trains with DCC and a separate one to operate LCC and all of my accessories. Is that right?
That would be the idea. Yes. Yes, okay. It would be necessary. The little little boards that you'll see in a few minutes, you feed power to. It either comes through a Cat5 data type cable, or you might have a wall wart plug-in, but it's completely separate power and has no direct power connection to your train layout operations. And let me jump ahead a couple here to say that LCC can run and work and interact with railroads that are AC, are DC, are DCC, DCS, all of these different, even the dead rail can be used, and you can hook up your accessories to work with any of these systems and have no direct connection. As I say, to detect a locomotive or the cars that have resistor wheels in them to conduct a little current, you have a small transformer that a wire passes through on its way to the track. So it doesn't connect to it, but it detects the fact that there's current flowing through it so that you can say there's a train or part of a train, if you will, on that particular track, thereby either setting a signal, setting your grade crossing or something like that. But it keeps everything completely separate.
And the reason you can say that LCC can operate with all of these track powers is that LCC has nothing whatsoever to do with operating a model railroad.
That's right.
The detection circuits you're talking about have absolutely nothing to do with DCC operating the model railroad. All that is a separate accessory that has nothing to do with the operation. Is that right?
That's correct. As I move ahead here, we'll get one picture where you'll see these little orange donuts that you can pass a number 12 or a number 14 wire or whatever you're using. You don't do a lot of looping because they're sensitive enough that they pick up the fact that there is current passing through going to the track, and that sends a signal back to the LCC, which creates what we'll get to here in a little bit, we'll call an event. Gotcha. And so you're going to see that there's two things that happen with LCC. It's looking at your layout, and you may have a control panel, and you're going to create events by having someone push a button or by having a train move on to a section of the track, or a timer go off and say, it's time to turn the light on in the bathroom on the second floor of that building. And you can have the LED come on there for a random amount of time in the middle of the night, maybe 3 nights a week. We actually have one of those working down in Arizona that way. But that's not the railroad. It's part of the layout, and the railroad can cause things to happen, or the operators can cause things to happen, or just the fact that things are moving on your layout. A train is moving along, can create an event, and that event that happens, and I'll just talk about it here a little bit.
Okay, before you do that, let me go back one last time.
Yeah.
You talk about the proprietary systems. LocoNet, I think, was one of them, and I forget the other ones that you had on that.
Right. Yeah.
Slide. So, as I understand it, LocoNet, if you're using LocoNet, in effect, LocoNet becomes your LCC.
Yes, that's what they're doing. And the problem becomes that as you get that to being bi-directional, and what you've done is you've taken your train control system that you're running your locomotive. And let's say there's 4 or 5 or a dozen people running locomotives on a layout, and you're getting other activities like turning switches or detecting the fact that there's a train on the track. That information is having to be sent over your network, and that takes up bandwidth. So as things build up, you lose bandwidth for running your trains. And the effect tends to be, and you know, you have to get to be a bigger layout really to have this really show up. But the effect is that you end up pressing your let's say your number 5, which I ran into yesterday at a layout, for calling for a grade crossing. Now, you know, it might have detected the grade crossing, the gates are going down, you press the button, but all these other things happening on the network, you might be halfway through the grade crossing before the engine gets the DCC signal to run the program built into the decoder on the DCC that gives you the grade crossing. Where if you didn't have all this other data running around in your system, running other than talking through the track to your trains, you'd get faster response. And the idea with LCC is it uses extremely high-speed data, and it's not, of course, connecting at all to your control of your trains. So, you know, DCC goes back to what, 95, 90, early 90s. And so we're now in quite a bit of different data structure, but we're maintaining our DCC systems because all of our DCC controllers in our locomotives and that still work with that. So with LCC, we can send the data faster, but we aren't trying to run the trains. We're trying to avoid having any accessories have any effect on the sending of information from the engineer to the locomotive. And so, as again, I say, it's all accessory. You know, I mean, if I went back to a Lionel O gauge, let's say, where you pushed a button, you moved the lever and it threw a switch, that was a separate thing. It wasn't drawing, it wasn't sending information through the track. The track was getting its information from your power pack, and the throwing of the switch was separate. As we get into typing an option or a code on our DCC controllers, we're sending signals over the same data system. We're sending signals over that system to tell a turnout to move, and that's taking up bandwidth. So by separating the accessories from running the train, we keep the DCC pure train operations, pure control between the engineers running with their throttles and the locomotives responding to it. Does that answer your question a little bit?
That totally does. Thank you.
But Paul, that only addresses a very specific vendor-based system. And the bigger control system out there is based on, you know, CMRI,
right?
And that model, which is a different model. So, you know, I think that's more what one should contrast to as the other option.
Yep. Yeah, and it is. And I followed CMRI from the beginning. I've been involved in that. I've got all the books on it. I've got all the operations. The interfaces in that are a little different, and it uses a control. I think the issue there was that was basically a proprietary information. I really like CMRI.
Well,
I like CMRI from the beginning. As I've gotten exposed more to LCC and what's available, and as we get away from the CMRI base systems and trying to keep up with the programs and so forth, that's where I see difficulties there.
Yeah, I think so. I think there's a discussion that should be had because LCC has only, I think, one manufacturer. And
well, there's more than one, but there's
only one I can buy.
RR circuits right now is
the only one you can buy. But I guess what I'd say is, and let's not have it right now. Maybe we can have it at the end.
Sure.
But the reality is there's a very significant architectural discussion that is fundamentally different between the two systems.
Yes.
And I have yet to have anyone articulate the benefit of that architectural decision structure, especially in large layouts, and even to a great extent in small layouts. So, you know, if we can have that discussion, because I think the reality is when you talk about something, the contrast is, do you do the distributed nodal intelligence of LCC,
right,
with basically a nodal publish and subscribe model, or do you go with a centralized intelligence with distributed stateless initiation? So it's stateful nodes versus stateless nodes. It's a fundamental architectural discussion in computer science that I think really should be had, because I'm not sure anybody's actually had that discussion and about the benefits. So basically, this is what I've done my whole life. So I think it's a discussion to have. So that's why I think you contrast those two.
Yep, I fully agree with you there. And because this is as an LCC presentation, I didn't go into that. I did mention CMRI, and I practically attended every CMRI discussion at nationals and all that. And as I say, I have all the documentation, and I followed that technique.
Right.
One of the other things that we were doing as modular layouts was using Arduinos to do a lot of this that you could distribute. Before we had the RR circuit equipment and so forth, we were sending signals in a similar fashion that you can understand how we would be following that.
For modular systems, it's absolutely. But we'll talk about it at the end.
Right. Okay. Well, let me move on here. And on this one, we see that we have the cards, or the basically the boards that make up what you were speaking of. Yes.
Let me ask you. I hate to break in like this, but you know, hearing what Phil just said, let me ask this question. I've got a small layout, and I want to run my trains with DCC, but I don't want to take the control of my trains away. So therefore, I need another system for my accessories. Now, if I use CMRI or LocoNet, I have a way instantly of buying whatever I need and plugging it in, and I can run my accessories separate from my DCC. Is that right?
Not separate from your DCC with LocoNet, but I believe you would be completely separate with CMRI.
Okay. With either LocoNet or CMRI, I would be getting the same benefit, I guess, as I would from LCC. Is that right? Is that what I'm hearing?
No. With LocoNet, you're using your communications of DCC communications with your DCC, but with LCC and with CMRI, you're removing the accessory activities from the running of the trains. So the discussion that we were just touching on has to do with whether we use a computer as a control point and have wires out to sections of the layout and let the computer do the work and all separate in CMRI with a computer looking at everything and making decisions, running a program, or whether you have things like these cards that I have presented here that are sending signals to each other and are a peer-to-peer system that doesn't require a centralized computer. And that's the discussion of the difference where we get into, is it CMRI that we should be following, or is it an LCC development that we should be following? And so because you asked, about LCC, I based all of this purely on LCC. And didn't get into the idea of, the contrast with CMRI, except that CMRI is using a centralized computer, and the LCC is a peer-to-peer system.
Gotcha.
And so,
but both of them accomplish the same thing.
Yes.
Gotcha.
Yes.
Okay. I'm sorry. I'm sorry to interrupt you.
And I mean, the real difference, and this is that discussion that could be a deep discussion that would be great fun for us, especially those of us who have been around computers from the time that we built our original Intel computers and, plugged boards in and soldered them all up, to things that you put together today where you buy and plug things together and make things happen. The speed with which all of these things happen and the way you control them and all has improved dramatically. I mean, when we were first doing CMRI and it came out in the magazine, we didn't have the type devices that we're using right now, and we certainly weren't talking video to each other. So the technology has moved along, and CMRI development people have moved along as well. I'm part of their work group, not work groups, but following along with the .ios and all of that in CMRI, as well as LCC and DCC. But in LCC, to go on to just continue on about this LCC variety of doing this, we have an interface that interfaces to usually a laptop computer for configuring the system. The system is not smart. It's smart, but it doesn't know what you want to do with it. So the interface allows you to communicate and allows you to do things. You use JMRI to set the volume of your horn, or possibly even to change the configuration of which button does what on your locomotive. It sets your speed, your starting voltage, and so forth. If you want to, you can use JMRI to interface in there. With this, you can use JMRI to tell these next units that we call the brains what their functions really are. And then the function activities take place on the daughter boards. And so right now, as we said, RR Circuits is the example that we're working with here as the major seller of devices. People build their own, but again, that's off on, how far do you want to go and spend your time. Some people build houses, some people build bridges, and some people wire signals, and some people do it all. And the idea is to make it as easy as possible. So this is what they refer to as the world's simplest LCC. There'd be a power, you have to have power, and you have to have a node, in this case, a signal card. That's one of the brains, and a daughter board on the side. And then to communicate with it, you have a buffer to talk to a computer to set it all up. When you unplug this and you turn your, after you've configured it, you can unplug this, and you no longer are utilizing the computer, the central computer, to do anything. The boards work and communicate among themselves. To look at the two brains of the system, such as they are right now, you have the tower, which has basically 16 lines of either input or output that can be used. And you have the signal, which has the capability of driving LEDs for your signals, and has input and output lines that work on the NMRA design of using the CAN bus. The CAN bus you'll find in your automobiles, talking between all the systems in your car. One of my friends just had his Cessna 172 switched over to glass panel. It uses the CAN bus to communicate between all of the systems to read out on his panels to get the information and be able to fly the airplane. It's the communication. If you see the data communication ports here, those are connections that are plain standard Cat5, RJ45 connectors, the stuff that you have between your computer and your network and so forth. And they can run in between all of these nodes, and they carry everything that happens. So if we go to the daughter boards, which can be plugged into these cards, either with a direct plug or with a wire, you can have occupancy detectors. And here's these little orange occupancy detectors. You run one wire through these, and then two wires of this go back to the occupancy detector board. And when this orange transformer here notices that there's current being passed through the wire that goes through there, it comes back here, and the block occupancy detector will then tell the node, the brains, if you will, that something happened. It created what we refer to as an event, that particular track was occupied. There's something drawing current on that section of track, and it just tells you that. What you do with it depends on what you've configured for when that event happens. That event might go to a stall motor driver board that could drive a tortoise switch machine to say, oh, there's a train coming on this track. I need to throw the switch, if you will, to allow that train to go through the switch without derailing. And there's a lot more to configuration. There's learning curves with this. There's a lot of learning curves with CMRI as well. But the event that occurred because current went through here caused this board and its logic circuit to send a note, a an event out to the rest of the layout, the LCC part of the layout, that will either use it or not use it. And then there's block occupancy detectors here that also have the capability of throwing switches. So you get to a point control board like this, and you have the plug-in to, let's say, a signal board. You have 4 occupancy detectors. You can control 2 turnouts with this motherboard. You can sense what's happened to the control board, to the turnouts if you wish. And the interesting thing about it is that they've designed this track power pickup in here. So if these 4 blocks are being fed from the same track power section, the same basic set of power, if the power goes out, of course, when the power goes out, let's say you short the, someone runs a switch, shorts the layout, and the breaker goes out and the power stops. The current going through the transformers also stop. So do the signals all go green and tell everybody else on the layout that there's nothing on that track? Well, it could, but they've built this in so that if the power drops out, these are locked. And so the red signals that were caused by some of these, red, yellow, and possibly green, stay locked until the power comes back on, and then they can be read again. So that's just some of the fanciness of a control point. A turnout controller can have a set of wires that will send signals to either stall motor switch machines or to the relay type, the solenoid switch machines, depending on which card you get. I'm going to move ahead a little quicker and get to this. Here's all of the activity for that fancy passing siding that I talked about. And you can see that we've got a control computer here that was used to buffer, to set things up. You don't have to have it when you're operating. But if we look at one end of it here, you'll see that you're detecting with these transformers, you detect whether track is occupied, and that's going down into the board that is deciding whether there's someone occupying the track. The information from that can be sent to the signal logic board, but it also then can say, well, the occupancy has control to have a switch motor, which is connected to this, which someone on the fascia decided that switch motor should be changed. They pushed a button that was sensed by the card, and the card, through the logic, throws this switch. When the switch is thrown, it's sensed and creates an event that goes to the signal logic, which then sets the colors. And there can be all of these signals that you see here, all the signal heads would be set to the appropriate colors, depending on what was occupied and what isn't occupied and which way the turnout is. Does that make sense as to how one end could work?
Hey, Paul.
Yeah.
I have set this up exactly as this schematic is portrayed. And one of the things that I can point out is that like the BOD 4CP, block occupancy detector control point.
Right.
Different parts of that board, as what in your diagram, do different things. So while some of the boards have like 16 lines that you can set up for any kind of function, that board is pretty specific in what it does.
Yes, it is.
And it's tied by that 10-line ribbon cable.
Yes, it is.
Signal LCC, which can display up to 16 aspects. Now, you're right, somebody can push a button on the fascia to change the turnout on that, or the switch on that at that control point. But if you have a panel set up in JMRI, you wouldn't want somebody doing that unless they called the dispatcher and said, "Can I turn?"
Well, yeah, you can actually lock those out. But in configuration, you can lock the fascia buttons out. And if you're running with a dispatcher and a computer on there, the dispatcher can control what those switches are doing, and the signals will still, the two boards will work together. The data coming in and out of those blue cables can be coming from a JMRI control panel on a computer, or from a homebrew control panel, or a set of buttons of a control panel that you built for yourself, or converted from your old direct wiring, whatever. But yeah, the information is not just kept in this little segment, but yes, the BOD 4CP is really quite significant for the purpose that we see here. And I've got them hooked up that way also, and have them operating. The signal head set up, depending on how you set it up, it's designed for 4 signals with 4 different LEDs in them. If you want to, you can make it 5 with 3 colors if you don't have lunar on any of them.
One of the confusion points that I run into, at least in my local NMRA group, is people don't understand, what is the role of JMRI in this, or what can be the role of JMRI in this. And I try to tell them that, you can create a panel in JMRI, and you can control your turnouts and therefore, your signaling through it. But it's also the window into the control, the CDI, the computer interface, that's built into these brains, okay, to use these boards. So it isn't a program somewhere in JMRI, but JMRI sees the program in these boards, and through JMRI, there are menus within the CDI that you can see. So it's really just a window into the configuration tool that's built into the boards.
Right.
So I do have fascia buttons. I've actually got touch triggers from Barrett Hill, touch buttons that turn red or green, and I don't use tortoises. I use the MP1 switch machines from Model Railroad Control Systems.
Sure.
And I've tested this with push buttons, momentary push buttons, and things like that, and it's very robust. I mean, it works. Once you set it up, it just works. You don't have to fool with it or no program update or any of that kind of stuff. But so that's what appealed to me. And I'm not an IT novice. I just retired a few years ago, but I was in IT since the early 80s. So I've actually, board built XT computers and forward. So I've got some experience in IT. But the learning curve on this is tough at first.
That's right.
Once you have your aha moment, it's like the light bulb comes on. And it's like, oh, well, this is easy. I just, So anyway, I just wanted to hopefully my comments reinforce what you're trying to present.
Well, good. I appreciate that. Yeah, I go back to designing computer aided instruction back with Plato 4 at U of I in 1971, 72. We were building terminals and sending them out at 1200 DPI over phone lines. That was one of our first that we sent out. But yeah, I mean, we interfaced railroads with that and with PDP-8s, but you see the appeal. You understand the appeal of once this is set up. And if I were to scroll through, I mean, the idea that this system, instead of talking to an individual like our DCC talks to a locomotive, the LCC talks to the world and anybody who needs information, and that can be your signals or your crossings or your control panel or whatever, gets the information. And, you know, I'll skip through this, the fact that it's peer-to-peer and we all have our identifications and so forth. And that, you know, the idea of the self-describing, you've mentioned that has to do with when you're connected to the JMRI and you configure, the system tells you what it is, and then you tell it what you want an event to be. And what we've been talking about, some of us have experienced this, some of us are new to it. An event is an LCC event is saying that something has happened or something should happen. It goes out over that network to every LCC device, and the device decides whether it wants to do something with that information or not. And the idea would be that, you know, you set the turnout, we talked about that. And then that's what we use when we're talking about producers and consumers. The producer side of things creates events. The current transformer or the push button sends an event out over that system, which you see on your JMRI panel, or changes a color on a signal or something, or maybe nothing. And it could be just the current transformer. The consumer responds to what happens to an event if it's programmed to do so. So it could be a lamp or a turnout or anything else that you can control. The event can trigger nothing, or it can trigger several of these items. As we say, the events, an event can have from one to many producers. That's where your control panel can send a signal that means something. Your push button on the side of the layout can send the same thing, turn that turnout. So you can create the same event from a number of locations. Not generally, but you can do that. But an event may have no or many consumers. It may affect a lot of things or nothing at all. The idea of an event that we've talked about is a button's pushed and it creates an event. It says this button was pushed. The producer says, oh, I'm the light that's supposed to turn on when that button is pushed, because the data information that was configured said do that. And you can have two different buttons around that might turn that light on. So that's all part of the idea of the events or the producers and consumers. Producers create events, consumers act on the events. And these are some of the things that fall into those aha moments. And here is a sample system that I have. I don't know Whether this video is going to play well for us or not, we'll see. It doesn't seem to be. Okay, now here we go. Run it at the same time. This is simply running through 3 blocks, a locomotive, and we'll see the lights change down on the system as they're detected. You can see the detectors hanging up there. Here we go. Okay, we're moving and we're about to go in. We just had, let's move over because we just had that light come on. We're now in 2 blocks. Now we're out of the first block and into only the second. And now we went into the third. And we're about to go out of the second and all the way to the end. We'll go back. Now we're in 2 and 3. Yeah, 1 and 3. Now by itself. One, 2, and only in 1. Okay. So we ran this example down at the Capitol building in Arizona, where they're building a layout that's basically all accessories are LCC. And this little example here uses an NCE connection and a computer connection if you want it. And you can program things up to run a crossover with 2 switch motors or a separate switch motor. You can have them triggered by events of the train moving along or by using push buttons. And this is purely a test bed that we use. We have a couple of these set up that we communicate with each other and talk about it. These are some of the things that I point out that are things to think about in it. Configuration can be tedious at first. It's a high learning curve. Lessons to be learned, we'll talk about in just a moment in planning. The configuration, I use the JMRI in their Panel Pro, and we'll see some experience here from Arizona. A quick going back to what's producers, consumers. You can have all of these items could be producers, push buttons and detectors and switches and so forth. Consumers can be all your gates, lights, LEDs, anything. And then some things can be both. And, you know, a tortoise it's a consumer that's being told move somewhere, but these points that are in the single pole double throw switches inside can be producers that say what has happened, which way has it gone. So you know, they all can work together and talk to the boards, the signal boards. This is just a quick shot here. Mine is set up with OpenLCB. You click in here to get into the control in JMRI when you're using it as a tool, and the system will tell you what you've got hooked up. This is that test system, and it shows that there's a couple of smart boards and what they are and what we've named them and so forth. You go in and name these what you want them to be. You set the names and you set the descriptions. The manufacturers and the type of information remains the same, much like your decoders. It gets complicated. As I say, configuration can be complicated, but as in here, you can put your name, you can put what it's going to do, you can pick out a button or an input and say what you want it to be. that's a learning curve. It's more than this is set up to talk about. So to take a quick look down at Arizona, there's the museum. Here's the layout. You can see the multiple levels. It's under construction. We were kind of locked out of there for both COVID and political reasons. The whole capital area of the Arizona Capitol was surrounded by, first of all, it was locked out for COVID, and then it was surrounded by fences, and so there was little activity going on. But in working on this, we say there's a learning curve. You have to take it step by step. The idea of having that test bed gives you a chance to play around with different things. I have one or two of just about all the boards on mine that I can plug in. There isn't a lot of documentation out there yet. This book you can get. It's a nice book to read. If you get it, get the book. If you get it on your, if you put it on your iPad, which you can get, it gets real confusing because it's not well organized from page to page. There's user groups and so forth. The manufacturers, RR circuits, and that have extremely nice presentations about the equipment and explanations on how to use it. And you don't be afraid to ask questions. There isn't any dumb question at all on the networks and so forth. The idea is to take it slow. Once you learn it, it's repetitive. I think you mentioned that. It's a steep learning curve to a point. When you hit that aha, then you're able to move along really nicely. And the recommendation for creating this is just out there to run everything along with the railroad. And, planning, if you name all your switches and have mileposts and so forth, it makes it easier to program and to configure things. And then the idea of this network that's daisy chained, you can have that set of boards out near the equipment it's working with, so you don't have a lot of wires. You have a data cable going out to it, and all the little wires for your signals. We had 4, 8, 16 maybe wires to LEDs, plus the grounds and for the signals. And we had 2 wires going to and 2 wires from the tortoises. And then we had a pair of wires from each of the detectors. They don't have to run all the way back to the control point. They can run to the local node, and the information is still sent over the data cable. So you put them around and have them out where they're closer to what you're doing. Again, putting them together, because the cards are made up in these configurations, it's kind of best to do that. The current transformers, we found that we can put those little orange current transformers back near their breakers and use it that way. The real recommendation is that you have it near where it feeds the track. We found very little difference in our operations, whether we have them back where the power is coming out of a particular breaker, or whether we have it out where it's feeding the track. Now, if you're using subsets of that, where you want to have a section of a power section that is the grade crossing, you can put another detector just on that and it will send the data. Isolating is quite the same thing. Blocks should be completely isolated instead of having a common side. Sub blocks I just mentioned using, and there's all kinds of things that you might put together and think about, because there's Arduino activities, and as I say, there's PIC activities, there's all of these different things that can be hooked up and put into it. Right now, the situation out there is 66 signals and 55 of those BOD4 CP cards, and they've gone in without letting the magic smoke out, except for one little situation where a person made a mistake and hooked the power up backwards. That was not an issue of the equipment itself. It was just something that somebody did at the wrong point. As you can see, this goes back to where we were at Salt Lake City and convinced to use this. And at nationals, we've had all day activities. If you want to get into this, and I know that CMRI is almost the same way. I've spent a day with CMRI presentations, and I've spent an entire day from breakfast to well after dinner just with food breaks with LCC. There's just a lot of information about it, and I hope that this gave you some idea of what it all is. I'm thanking the Railroad Club, Jess Poole, who is the president there at the Arizona Railroad Club. We've worked together on this. And then Karen and Dick Bronson, who own RR Circuits, I came to know at the last actual national. We were traveling around. I went to their presentations, but we were also running into each other on layout tours and so forth. And Dick goes back to the PDP-8 side of things as well. So pretty much that's my presentation. And I will do the stop sharing there and just give you my picture. And I'm open to questions, and if necessary or whatever, we can work on other opportunities or discussions about this. I hope it was, somewhat informative.
Well, it was for me, because I've never understood it before, and I cannot believe it, but I think I understand now what LCC is. And I think I understand why, regardless of size of layout, I ought to look into it more. So I can't thank you enough, because you've really opened my eyes to what it's all about.
I'm glad to hear that, Jim. Really, thanks.